Hey guys, welcome back. So today we are looking at 1.4. This one is called Rabbit Run. All right, so let's go ahead and get started. So the first thing we're looking at here is calculating the slope of the line between the given points. And afterwards, you guys will take and determine which line is the steepest, but I won't do that with you. We'll talk about later how to determine the steepest line. So we're going to take and look at number 2. So for number 2, it had the point h is 12, negative 37, and k is the point 4, negative 3. I gave you guys a slope formula just as a reminder, y2 minus y1 over x2 minus x1. So this is our x1, y1, and this is our x2, y2. And so then we're just going to plug these into this formula. So our y2 is negative 3 minus our y1, which is a negative 37, over our x2, which is 4, minus our x1, which is 12. Oops, sorry, you can't see that. Okay, so far we have this. Now we're going to do our negative 3 minus negative 37. So remember, when we have minus a negative, we cross and stab. So we really have negative 3 plus 37, which is going to give us a positive 34 over 4 minus 12 is going to give us 8. So we have 34 over 8. Now, can we reduce this down? Yes, we sure can. So both of these are divisible by 2. So 8 divided by 2 is 4, and 34 divided by 2 is 17. Now, did I forget something? I did indeed. 4 minus 12 is negative 8, which means that's a negative 4. Don't drop your negatives like I just did. So you got to be super, super careful of that. So our final slope is 17 negative 4, or negative 17 fourths. Okay? So this is our slope formula. So make sure if you don't have slope formula wrote down, you get that wrote down. If you want to pause the video, you can right now to get that wrote down. It's a formula that you definitely need to know. So write it down, memorize it, practice with it. So these first 4 questions here are all about slope. And you will take, and after you find all 4 of them, you'll determine which slope is the steepest. And like I said, we're going to take a look at that here in a little bit. We're going to move to the next section. And then the last section is looking back at our slopes again and determining steepness. So then we'll talk about that then when we have a nice concrete way to show that steepness, okay? All right, so this next part. There's a lot of reading here, so bear with me as I read through this and feel free to read along as I go. Adam and his brother are responsible for feeding their horses. In the spring and summer, the horses graze in an unfenced pasture. The brothers have erected a portable fence to corral the horses in a grazing area. Each day, the horses eat all of the grass inside the fence. Then the boys move it to a new area where the grass is long and green. The porta-fence consists of 16 separate pieces of fencing, each 10 feet long. The brothers have always arranged the fence in a long rectangle with 1 length of fence on each end and 7 pieces on each side, making the grazing area 700 square feet. Adam has learned in his math class that a rectangle can have the same perimeter but different areas. This is a true statement. He is beginning to wonder if he can make his daily job easier by rearranging the fence so that the horses have a bigger grazing area. He begins by making a table of values. He lists all of the possible areas of a rectangle with a perimeter of 160 feet. While keeping in mind that he's restricted by the lengths of his fencing units, he realizes that a rectangle that is oriented horizontally in the pasture will cover a different section of grass than one that's one that's oriented vertically. So he's considering the two rectangles as different in his table. Use this information to answer questions 5 through 9 on the next page. So we've got our horizontal and our vertical. And I know I just read through a whole lot, but basically what we're dealing with is rectangles, and we're looking at perimeter and areas of rectangles and seeing how we can have the same perimeter but different areas. So the perimeter for all of these will be 160 feet. So if we have 1 unit of fencing in length, we have 7 in width. So length is 10 feet, width is 70 feet. So that's 80. We double that because there's 2 more sides to finish off the rectangle. We get 160. 70 times 10 is 700 feet squared. I'm going to zoom this in so I can write better in a second. So what we need to do next is figure out if we have 2 units in length for the fencing, what should the width fencing length be, or fencing width be in units? Well, it'll be 6 units. So then our length in feet, each one of these, each one of these fencing units is, it represents 10 feet. So if we have 2 units of fencing units, then we have 20 feet in real life. And so then this is 60 feet. Now, 60 and 60 is 120, plus 20 is 140, plus another 20 is 160. So the perimeter is the same. But 60 times 20, or 6 times 2, is 12 with 2 zeros feet squared. So it's 1,200 feet squared. Significantly larger than that 500 feet squared that they've been giving the horses. So for 3 units, if it's 3 units in length, then it's going to be 5 units in width, which is going to make this 30 feet and 50 feet. Perimeter, double this, we get 100, double this, we get 60, add them together, 160, so that is true. 5 times 3 is 15, so 50 times 30 is 1,500 feet squared. Remember, area is always going to have a label of feet squared. Now, you guys are going to complete C, D, E, and F, so you're going to keep going through here and finishing the rest of these off. Remember, they're all going to have that perimeter 160 feet, and then you need to calculate the area, okay? And that's just multiplying your length and width together. So then based on this table, you're going to take and answer number 6. So discuss Adam's findings. Explain how you would rearrange the sections of the porta fence so that Adam will be able to do less work. So less work means that there's a bigger area for the horses to graze in. So we want the largest area possible. So largest area possible. So that's what you guys are going to be looking for in this table up above. You want to find the largest area possible based on this table, and that's how it's going to make it so he can do less work. After you do that, then you're going to make a graph of Adam's investigation. Let length be the independent variable, which means your x value, and the area be the dependent variable, so that is your y value, and then label the scale. So you'll do that right over here. So make note, it's length and area are your 2 variables, and length will represent x, area will represent y. Then you'll answer some questions about the graph, okay? All right, the last section, comparing linear and exponential rates of change. So remember, rates of change is another word for slope, and slope is your key word for this lesson. Slope is your key word for this lesson. So indicate which function is changing faster or which has the steeper slope. So this is what I was talking about before when we're looking at steeper slopes. I'm actually going to use the highlighter tool. Oh, maybe. Sorry, it's really big. Too small. But anyways, for a steeper slope, that means it's going to be straighter. So it's going to be closer to being vertical. The more vertical your line is, the steeper the slope, which means it's not going to be a fraction for a slope. So 1/2, that's not a very steep slope. 5, that's a steep slope because you're going up 5 and over 1. Whereas with a half, you're going up 1 and over 2. So that's a very shallow slope, whereas the whole numbers are much wider. So if we look at this graph, if we start here at this right here, and we follow the line to see which one is which, this bottom line here, which means the less steep one, is our g of x, which means our steeper slope is f of x. So basically, it's the slope that's on top at the furthest to the right point. So be careful with these. With the x-axis, this right here that I'm highlighting, that I'm drawing the line for, this is your x-axis, and your equation for h of x is up here, and then d of x is the diagonal line. So be really careful with that. So you're just going to base it off of what you can see, which function, and well, yes and no. You're going to base it off of what you can see and what you think will happen. So I'm going to do number 11 with you as well because this one's weird. For the entire part that we're seeing, h of x is greater. It's got a constant slope, so it seems steeper because it's on top, but it's not actually steeper because it's got a slope of 0. D of x has the steeper slope because it is going up. So a horizontal line will never have the steepest slope because it is a slope of 0. So always remember that. So that's what you're looking at with these. And then for 16, you're looking at this graph specifically, and you're determining which you think is faster over certain intervals. So at the left from 0 to 1. So that means from the origin to 1. So from there to there. Then it wants from 2 to 3. So then you're going to go from here to here and tell me which one's growing faster. So be super careful on that number 16 because you're not looking at the whole thing. You're looking at specific intervals. Okay? So that is what you guys are looking at for this lesson. It's a lot to do about slope in here. So remember, slope is your key word. And remember, the steeper it is, the closer to being vertical it is. Okay? Alrighty. Have a wonderful day. If you have any questions, always feel free to reach out. Bye-bye now.